Hey guys, welcome back to the channel. Today we're going to be solving LeetCode number 33. Problem says search in rotated sorted array. Feel free to pause the video just to read through what the problem is asking for, or feel free to use the link in the description to go to the actual link of the LeetCode problem. However, I find the examples more explanatory. So given an array nums, okay, is sorted and then rotated about a pivot point, okay, and the target, given a target, we want to find the index of the target. In this case, 0 is index 0, 1, 2, 3, 4 is the fourth index. If we're given an array and a target, but the target is not in there, we want to return a -1. So that's pretty straightforward. So let's get our hands dirty. Okay. So a quick way to do this, or the first way that might come to mind is brute force. Just iterate through the array and get the values you want. For instance, we could say if target in nums. Okay, target exists in nums. What do we want to do? We want to return. What do we want to return nums? So Python has a method called index. Okay, we want to return nums with the index of that target. Okay. Else, okay, if it doesn't exist, okay, we want to return -1. Okay, this is quick, dirty solution. So let's see what that gives us. Okay, it's not too fast. 9.7. Okay, memory not too bad. Okay. So that's one way. Okay, the second way, again, also dirty, brute force, is literally to iterate through it. So for I enumerate nums. So we're literally going through all the elements in nums. If num, if our specific element equals the target, if we get to element that equals the target, we want to return I, which is the index. Okay, else if we go through the for loop, nothing happens, we want to return -1. Okay, this should also be correct. Okay, slightly faster, worse memory, but however, while these two methods work, this is not what the problem is asking for. The problem says to do it in log n. Those two I just showed you, they are linear time complexity of O of n, which is worse than log n. We want to do it in log time complexity. Okay, so anytime you see log n, think binary search. Okay, so I'll show you how we can do with binary search. So this is pretty straightforward. Okay, standard for binary search, first you need a left and a right pointer, okay, which is always equal to 0, and the length of the array -1. Okay, pointing to the first and the last index. Okay, and after this you need some kind of while loop. Okay, standard while the left is less than or equal to the right. Okay, we want to do some stuff. Okay, what do we want to do? We want to calculate our mid value. So our midpoint, this is pretty standard, it's just the right plus the left. Floor divided by 2, just to avoid float numbers. Okay, now the first step is, say for instance, let's show an example real quick. Okay, say for instance we were given the number, or we were given the example 1. Our array is 4, 5, 6, 7, 0, 1, 2. Okay, just to picture this, let me draw a graph and show you what this kind of looks like. This is what this kind of looks like. This is 4. Okay, first element is 4. He's rising up until 7. He rises till 7. At 7 he hits 0. He makes a quick drop, sharp drop down to 0. Okay, then starts back and stops at 2. Okay, so these are our indices. Okay, let me use red. Okay, so this is 0 index, this is 1 index, this is 2 index, 3, 4, 5, 6. Okay, so this is what happened. This is our 6th index. Okay, this is our 0 index. So, and this point right here is 2. Okay, this is where he stops. Okay, this is what happens. So like always, we have our left pointer. Okay, starting off we have our right pointer, and our mid is somewhere in between. Okay, based on the calculation. But just say our mid, or let's go back to the code just so we can work through. So we're at this point, we have our mid somewhere. Okay, somewhere in the middle. Okay, our first step is to say if our target, okay, if our target equals the mid, meaning somehow, like in this example, meaning say our target was 7, say t equals 7 target, which happened to be our midpoint when we calculated this is mid. Okay, if this is the case, what do we want to do? we just want to go ahead and return mid because we're returning the index, right? That's straightforward. Okay, however, if this is not the case, if, which is our next test, if nums of L, which is the leftmost guy, if the leftmost guy is less than, okay, or equal to, okay, if it's less than nums of mid equal to the mid value, okay, if it's less than or equal to the mid value, what do we want to do? Okay, this is in the case where, say our mid is 7, mid is right here, mid is just 7. Obviously our leftmost guy is 4, okay, he's less than or equal to 7, meaning we're searching in here, okay, that's what it means. Why our else case means we're searching here, else case means we're searching in here. So for now, let's just say pass for now, and let's do our else case. Okay, like I said, else case means we're searching the other part. Okay, so if it's in here, if we're searching our left side, we want to say if our target, if target is greater than nums of mid, okay, meaning, okay, let's try the second part. Our target is less than nums of L, okay, L. What do we want to do? Okay, we want to do move our left equals mid plus 1, okay, it should be equals. Okay, so let me just explain what that means. Let me move this to right. So this first if statement means if our target, okay, if our target is greater than nums of mid, say for example, let's move our mid to 6, okay, so let's move our mid to 6 hypothetically, all right, and our target is still 7. In this case, our target is greater than our mid, right, because our target is 7 and 7 is greater than num of mid, which is 6, okay, so which is this if case right here, okay, or okay, if I sound like a seal, if our target is less than nums of L, so if our target is less than this, nums of L is 4, if our target happens to be less than this, so in this case, say our target, if our target is 7, okay, or our target is, say, let's say 1, okay, 1 is less than 4, okay, what do we want to do? In this case, we don't care about, so if 6 is our mid, we don't care about this, we can cancel this guy out and just search in here, right? That is why we're incrementing this, right? Okay, now the else case for this, else meaning our target is on the left side, we want to search the left. So if the target is on the left side, so in this first example, we just change our L here, but in the else case, okay, it means we care about the left side. In this case, what we're going to do is, it means the target is somewhere here, so we're just gonna cancel all this guy and then move our right here, okay, meaning our target is 4 or 5. R is going to be equal to, obviously, mid minus 1. Okay, now the else case is we're searching on the right side, so this is literally, okay, literally the reverse of this if case, okay, target, all we just have to do is reverse the signs, opposite, okay, and then we reverse these two, okay. Okay, and then if we go through this array completely, this while loop, I'm sorry, we want to return -1, meaning he doesn't exist. Okay, so in this second place, we're saying our target in this second else statement, we're saying our target, okay, is less than num of mid, okay, or our target is greater than num of, this should be R, not L, okay, because we're looking on the right side. Okay, so in this case, we want to move our right, meaning he's not there. Okay, else this. So let me kind of show you guys what it means. In this case, our target is greater than nums of mid. Okay, so where's num of mid? Say our target is 6. Target is 6, and num of mid, the mid is 7. So say our mid was right. Let me actually wipe this off. Okay, so target now in this else statement, target is 6. Okay, so this is target, and this is mid. Mid is 7. Okay. Okay, or if it's in this case, we know we're searching somewhere here, so we just cancel this right guy. Okay, or if our target is greater than, so if our target is greater than the rightmost guy 2, okay, we know we're searching this side, we just cancel this guy out, and obviously the reverse is the else case. So let's check it and see. Okay, bam, this is a lot faster. Okay, and just less space. So that's it for the video. In the next video, part 2, we're going to step through this code on our visualization tool and see what's actually going on.